So, good morning, everyone. I would like to rush through the presentation we gave last week at the FOSS4G in Bucharest about GRASS GIS in the cloud. Just an overview of what we do, so-called actinia processing. This presentation has been done by Carmen. She's to the right. She prepared it, and she's one of the developers of actinia, which I will introduce now. This is most of our gang in Bonn. And yeah, what is it all about? So in some years ago, this idea of bringing algorithms to the data is nothing new, but we thought, why not exploiting the GRASS GIS functionality for that? As some of you at least have realized, GRASS GIS comes with a lot of stuff, which is probably relevant also to Sentinel data and others, but maybe not being ideal being used on a desktop. We thought of why not putting everything into a REST API. The original name was GRaaS, GRaaS as a service, but since that's from marketing speech not so easy to pronounce, we renamed it then eventually and called it actinia. So, GRaaS in the cloud. Those who have been attending my talk yesterday and Vero's talk yesterday know that GRaaS comes with a specific format with location, mapset, and so on concept. This is also somehow adopted in this actinia or reflected there. And we have so-called modules or the commands, which is a rich set of different methods. It's not unlike other GIS software, of course. And examples here, vector clipping, segmentation, time series processing, all the standard GIS stuff, and so forth. So, what about putting a REST API on top of that? Yeah, we have the functionality of GRaaS as it is, but we built a REST API around. We need to have then the possibility to look at those data, list them, of course, to enable GRaaS usage, maybe have some user management there. Not every user should use everything, but restricted by commands to be used or by amount of pixels to be processed, because we need to keep in mind that cloud computing costs money. Any computing costs money, of course, but you bought your laptop, you get energy for free here from the university, at least for free for you. In a cloud context, you have to order machines to run them, and they will happily charge you something. So it's a good idea to have some user control there in order to avoid that the user just burn your budget unless they pay for it. Then you want to have locking in order to avoid conflicts that one user can overwrite stuff of another user. This is already built in GRaaS. Yesterday I mentioned that you can store GRaaS data on a network drive and the entire team can use it at the same time. So there are two concepts which are relevant. We have the persistent data and we have the user data, which are like non-persistent, which means in the upper box you would store the base cartography and say, okay, this is the elevation model. You put it one time into your cloud space and then it's available to selected users. And you have the user DB where people do their own stuff, compute things which may disappear, say, after 24 hours because it costs resources, so they can download it or do whatever they want, and then it gets deleted. On the right side, you see basically the different GRaaS nodes, which we call actinia node because it's in the cloud context and they do the working. So we have the workers there and the GRaaS database and they interact somehow. And the entire job management is done in a Redis database because you have to keep track on users, who can do what, which jobs are executed, did they fail or not, so the job status and all this kind of stuff that is stored there. What we use as a technology is Docker here, and we have already been deploying it on OpenShift infrastructures in a rather large way in Kubernetes, and we also use Terraform. Terraform is a software which lets you order new machines and set them up. For example, you have a heavy job, you are splitting your data into pieces like tiling or whatever approach you use, and then you want to send it out to different nodes. In this moment, these nodes have to be ordered, installed or being pre-installed by Docker images and then brought up and put into the network that they are visible to Actinia. And this is done, among others, through this Terraform software. Well, and OpenStack we have also used, so you can see, you can launch this Actinia stuff on a number of different infrastructure types, let's say. It also works on Google Cloud and on Amazon if you insist. Then we have a load balancer. So you can imagine different jobs come in, there are different machines, they need to distribute the workload somehow, and this is done by a job manager. And the user is sitting somewhere and controlling the entire thing from remote. So if we look at REST, I will in the session talk a bit more about what it means. You can send so-called requests. It's not much different from calling a web page. If you, in your browser, put in a URL, then you get back something. This is a HTTP request. And here we have something similar. And if we say get locations, we send it to the server, then we retrieve back, for example, this answer. And this format here is called JSON. There you see another example. You want to know something about a detailed mapset, which is like a subdirectory in which data are stored. Then you can retrieve those information and you can see available mapsets, standard out permanent, Landsat, and something else. This is machine readable, that's the idea of JSON, but it's also human readable at the same time, at least more human readable than other formats. You can also look at data, say, show me all data available in that map set here, so the elevation model and so on. And you can also render them. You see, you attach render there, and then you get out a map. You can also download resources like GeoTIFF or vector format. That's also possible. Well, so user-defined processing. We do not only want to look at stuff, but we want to also compute something. We send so-called process chains, which are like one command after the other, chained together, stored into this JSON format. And I will show how to generate such lists in an easy way. And then you can go ahead and combine all the tools you have there on the system. And that's not only GRaaS, but it can be arbitrary Python scripts, GDAL. We have also put in Snappy, for example. So the ESA Snap software comes with a Python interface. We have a WebDet, so we have Sentinel-1, Sentinel-2 processing chains there. You can compute NDVI or do some radar differences mapping or whatever you can imagine. You can control everything from command line using the curl software, for example, and then you send the credentials. This demo user is public, so it's something we play with later on. And then you send as a file the process chain, or you send it as a JSON string to the server here, and then it does an asynchronous processing. So it means the JSON is sent to the server, it sends back a status, okay, I received it, or it is, I received it, but it is not garbage what you sent, I can't read it, or it is going into processing. And then you do so-called polling, which means you query, okay, are you ready, are you ready, are you ready? And then at some point you get something back. When the job has been executed, you get back, okay, everything is successful, here is the result. And then you can retrieve it. Or you can feed it, that is the idea, into a different process system. So what I want to say here is all this is all, let's say, backbone processing. You have maybe your own stuff, and you can hand out some job to this Actinia server. It does the number crunching for you. You get back the result in a machine-readable way, and you continue with your further processing. Okay, and then, for example, you retrieve some, I don't know, a shaded elevation model or something like that. You can do import and export. We have some set of predefined functions there, but you can write your own. The Sentinel I already mentioned. And you can fetch data not only from the ESA API hub, but also from local storage if Actinia is deployed there. So through OpenEO, we are, I think, still discussing with some of the DIAs if we can get stuff into them or not. We also have, as a company, some discussions running. Amazon AWS and Google Cloud Storage is there. The advantage of those two, there's the star, is that the Sentinel images, I don't know if you're familiar with them, ESA delivers them as pretty huge zip files, like 1 gigabyte per scene. All channels in one and a lot of extra stuff there. But if you want to compute, for example, NDVI, which is 2 channels only, from ESA you have to download the entire gigabyte. You throw away like 900 megabyte and keep the rest. With these two, they have unpacked everything in the cloud storage, and you can just say, okay, I want channel 4 and channel 3. And that's so much faster. So no idea if ESA is planning to do anything about it, but at least this is a way to do. So for Sentinel processing, another example, you just say server URL, you say I want to have the Sentinel-2 process, please compute the NDVI and use this scene. So this is the syntax, pretty easy. And then again you send it, you get something back, it does the number crunching and it tells you where to download the NDVI. Voila, there it is. Okay. What else is there? You can also store to cloud storage, to S3 and Google Cloud Storage. We have the so-called actinia command execution in GRaaS. This I will also show, which means we control from a running GRaaS session, we control the cloud, which is a pretty easy way to generate these JSON files, because you can write your Python script or your shell script just like command, 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 and then you send it and it's turned automatically into a JSON and sent to the cloud. You can deploy own stuff as add-ons. Who's interested, I can show. Maybe we don't have the time for that. And we have OpenEO support, which is getting gradually better. I know there's a hackathon upcoming. Now, since 24 hours, we can at least be discovered. So this has been fixed. So in the OpenEO web editor, you see now the list of maps available and the processes. Still, some things have to be done. And with all cloud people on holidays at time, I'm not sure if we make it in time. OpenEO you have, I think, heard about. And then we are also developing actinia algebra, which is a tool to massively calculate in parallel. This is, of course, the entire idea about cloud, that you don't just outsource your computation to a single node, because then you can also do it maybe locally, but to really split stuff into pieces and then do a massive parallelized number crunching and put results back into the final result. So what's upcoming? Implement more stuff and have also process self-descriptions, so that we can probably also wrap it one day to WPS. Not sure about that, if we really want to do it or not. Reprojection support isn't yet there. We have to do a full refactoring. So this actinia has been developed over a few years, but now we really want to refactor everything, make it more beautiful and so on. This will happen at some point. Using Swagger 3, for example, is also one part, but it's a big job. So maybe, I don't know, 100 days of work, not sure yet. And we want to get rid of the Google Cloud connection somehow and probably do more stuff in-house, but that's also a bit of future, or we need to find some financing for that. That would be cool. And enable use of dynamic process chains. I think this is also related somehow to OpenEO and to be covered there. Well, that's basically it. Importantly, Actinia is an OSGeo community project, and you can, of course, join us on GitHub. The code is available. You can see there we have also a GDI, that is an interface to metadata management in GNOS, GeoNetwork open source, so that we can retrieve also where are the sources. So you put all the, let's say, all your list of metadata into GNOS, and then Actinia Core can ask, okay, tell me where I get this map. Or I have a bounding box and I can retrieve, okay, what maps are available for this area from the metadata server, and you get the stuff back. We have satellite plugin and statistics plugin as separate plugins, and then we have the documentation, of course, of the API. Yeah, I think that's it, and available for questions.